Alright guys, so what we are doing today is we are going to go over the Chapter 3 study guide. The very first question is asking us what is a pure substance. In our notes that we took, we broke down matter into pure substances and mixtures. A pure substance is something that cannot be broken down further by physical means. This is an element or a compound. We've talked about it. The only way to break down a pure substance is by chemical means. That's the only possible way. Pure substances are some of the most purest and simplest forms of matter there are. Question number 2 is asking us to complete this chart. So, the very first one that we have, first state of matter, is a solid. For a solid, we have a fixed shape and a fixed volume. We cannot change the shape of a solid if we want to. It is going to stay in the shape that it is. We also cannot change the volume. Then, if we look at our picture, the particles are very close together. The particles do move though. Remember, all particles do, but in this example, they're so close together that all they can do is vibrate. Because they are as close and packed together as they can get, it makes solids incompressible or not compressible because they cannot get any closer than they already are. And that's what compressibility is asking, is if you can get the particles any closer together. All right? The next state of matter we're going to look at is liquids, okay? Liquids conform to the shape of its container. If you were to put a liquid in a glass and then to put it in a water bottle, it's going to conform to the shape of whatever container you put it in. Liquids also have constant volume. The volume of liquids do not change. If you look at the picture, the particles are close together, but not as close as they were in solids. The liquid particles have more area to move. Remember, liquids are fluids. They flow, which happens, and we can see this in our particles, is they have the ability to move around and flow. Because there is more room in between our different particles, it makes liquids slightly compressible. We can compress them. It's very difficult, but because of the space, it is possible. The next one is a gas. Now, remember, gases are gaseous forms at room temperature, all right? Gases have no fixed shape or volume. This is very important to remember. They also have no constant volume. They are the ability to move around free. Remember, they're a bouncy ball that never loses momentum, okay? In our particle diagram, they move around very fast, and there's so much space in between them, which makes gases easily compressible. So much space, easily compressible. Right, looking at question 3, it asks, is a change in state a chemical or physical change? Now, one way to think of this is if you had an ice cube and it melted to a liquid, that is a change of state. Is that a physical or chemical change? All right. A change in state is a physical change. Changing the state does not change the identity of the substance. So with my melting ice cube example, I started with ice, which is solid water, and I ended with water. Same material I started with, just in a different state, all right? Change of state is a physical change. The next question is question number 4, which says, describe the law of conservation of mass, and what does this mean for chemical reactions? The law of conservation of mass states that mass cannot be created or destroyed. Point blank, mass is never created or destroyed. It just doesn't disappear. So in a chemical reaction, the mass changes state but is never destroyed. We saw this when we dropped the sodium in the water bucket outside. We started with solid sodium, and when we placed it in the bucket, it exploded, but there was no solid left in the water. So instead of changing, it wasn't just destroyed, it went from the solid form and it had a chemical change that caused it to go into a gaseous state. The mass didn't just disappear because it cannot be created or destroyed. All right, so question 5 is asking to describe the difference between homogeneous and heterogeneous mixtures and to provide an example. All right. Homogeneous mixtures have the same composition throughout, while heterogeneous mixtures have different composition. Remember, the prefix homo means same, so we have the same composition all the way throughout our substance. Heterogeneous, if you're struggling to remember this, just always think of trail mix. You could easily separate the raisins and the almonds out of it. It's a completely different composition all the way throughout. Question number 6 is asking what are the 4 states of matter in the universe, okay? And then it also asks where can plasma be found on Earth? So the question kind of gave away the 4th state of matter, but the 4 states of matter are solid, liquid, gas, and plasma. All right, plasma is found in the universe. Now, plasma can be found on Earth when in lightning bolts. Remember, the temperature gets hot enough that plasma can be created. All right, question 7 is asking, can mixtures be broken down or separated, and if so, by what means? All right, we looked at this when we looked at our separation techniques. Mixtures can be broken down by separation techniques, and these techniques can either be physical or chemical. One thing to note is that mixtures can be separated by physical means. Pure substances cannot, but mixtures can. All right, question 8 is a conservation of mass question. It says I start with 12.2 grams sample of X, which reacts with sample of Y to form 7.8 grams of XY. What is the mass of Y that reacted? Okay, if you look at my question, I underlined what X is and I circled reacts. This reacts is telling me to add with a sample of Y. So X plus Y equals my XY compound. So that's what I wrote here in my equation. Then I just plugged in the numbers that I know. 12.2 grams of X plus Y, which is what I'm trying to find, equals 78.9 grams. And then I came over here and I showed my math. 78.9 minus 12.2 equals 66.7 grams, which is Y. With these problems that are math problems, they are worth 3 points. All of your work, your answer, and your units. So don't forget your units. That's a point that you could miss. Question 9 is asking what is the difference between a gas and a vapor? Remember, these words are not interchangeable like most people think they are, but they are different. Gases are gases at room temperature, and they're pure gases, okay? So they naturally are that state at a room temperature, while vapors are substances that are not a gas at room temperature, okay? An example of a vapor is steam. Steam is a vaporous water. Water is a liquid at room temperature. So steam is a vapor, not a gas. All right, question 10 is asking, can compounds be broken down, and if so, by what means and into what? Compounds are under that pure substance column, all right? So we already know that compounds cannot be broken down by physical means. The only way to break compounds down is by chemical means, and when we break a compound down, we are separating it into its different elements. So compounds can be broken down by chemical means and into their elements. Question 11. All right, question 11. Are the properties of a compound the same as the elements it is made of? Give an example of each, okay? The properties of a compound are not the same as an element, okay? One way to think of this is with your table salt. Table salt is a compound of NaCl, okay? You can eat table salt. What we used in the demonstration where I put sodium in the water and it exploded, sodium is an element used in table salt, but it has completely different properties, okay? Once it combines with the Cl, it's table salt, but by itself it's very explosive and reacts to water. Elements and compounds do not always have the same properties. All right, with question 12, we are filling in a chart again. What the chart has to do with our separation techniques. The first separation technique that we're going to look at is distillation. Okay. Now, remember when we talked about our relationship example, we want to find those physical differences between our substances and our mixtures? Well, for our example with distillation, the physical difference that we're utilizing to separate our substances is boiling points, okay? Now, there are two examples that I provided of distillation. We looked at the one in class of alcohol and water. Alcohol has a lower boiling point than water, so you could evaporate off the alcohol and be left with just your water. Another example that they provided in our video is separating crude oil. Okay, that's used for gasoline. Separating out the different hydrocarbons in oil is distillation. The second separation technique is filtration. Going back to our relationship, the physical difference that we are using is particle size. That's how we're going to separate our substances in our mixture. You have done this one in the lab when you separated the sand out of the water. You filtered the sand, and what was left in your beaker at the bottom was water, and the sand was in your filter paper. The next one is chromatography. Remember, there's two different ways of doing chromatography. You can do paper or you can use it with a machine. The one that we saw in class was the paper and ink example. We put a drop of ink on the paper and then the water climbed up the paper and it spread out the different colors of the ink. The difference that we utilized in chromatography was the particle speed. That is how we separated the mixture. Our next example is sublimation. Sublimation is when you go from a solid to a gas. You skip that liquid phase, okay? So an example of this is dry ice. You've all seen it before, but that's something that sublimates. There is no difference utilized. The only thing that's utilized is whether a solid can sublimate or not. That's how we would separate two solids that are together. One of them would sublimate and the other one would stay in its solid form. The next example is crystallization. Crystallization is when you add a substance and it dissolves, and you add more and it dissolves, and you keep adding. Eventually it will get to a point where you've added so much that the only place that the particles can go is to form a crystal. An example of this is rock candy, okay? So there's no difference utilized, it's just become so saturated that it has to be in its crystallized form. All right, our last question on this page is asking how can you identify chemical changes versus physical changes? And what are some signs that a chemical change has occurred? Now, the difference between a chemical and a physical change is if the substance is not the same that you started with, it is a chemical change. If I start with paper and I cut the paper in half, I end with paper. That's a physical change. I started with a substance and I ended with the same substance. A chemical change is when you start with a substance but you end with a different substance. Okay? That's the difference between chemical and physical change. Some signs that a chemical change occurred could be there was an explosion, bubbles formed, there was a gas formation, a precipitate, which the precipitate is when a solid comes out of a liquid, or when there's a different odor smell. When completing this question, guys, be careful. Do not put color change as a sign a chemical reaction occurred. Color change can indicate both physical and chemical change. So these are good examples of a chemical changing occur. Phase state, anything like that is a sign of a physical change. But don't just rely on color change for your example. Question 14 is asking what is a compound and asks us to provide an example. A compound is when two or more elements are chemically bonded together. Alright guys, sorry if I'm repeating this, but one more time, question 14 is asking what is a compound and to give an example. A compound is two or more elements chemically bonded together. Now, it's very important to understand two or more elements. Now, I provided an example of H2O, NaCl, C6H12O6. These are examples of a compound. If you see a capital letter and another capital letter in a form like this, it's going to indicate to you a compound. Compound is two or more elements. Mixtures are two or more pure substances. All right? Compounds are chemically bonded together. Question 15 is asking us to describe the law of definite proportions and the law of multiple proportions. We covered this yesterday in class, but the law of definite proportions says that no matter how much of a compound I have, the percent of the element will be constant. Okay? So if I have 2 grams of sugar, 40% of it will be carbon, and if I have 2 tons of sugar, 40% of that will be carbon. Always going to be the same percentage of elements no matter the amount of mass you have. Okay? The law of multiple proportions says every compound has a different ratio of elements. We looked at the example of water and hydrogen peroxide. Both of those are made up of the elements hydrogen and oxygen, but with the different ratios, it produces different compounds with different properties. Question 16 is asking for the chemical formula of water. Now, most of you know chemical formula for water is H2O. Then it asks for how many individual atoms are present. When it asks for atoms, it's asking how many elements are present. We have 2 different elements present. Both hydrogen and oxygen are in the chemical formula for water. Now, the very last question is a law of conservation of math question again. Just wanted to do a little bit more practice with you. So, we have a 28.0 gram sample of nitrogen, which combines completely with 6.0 grams of hydrogen gas to form ammonia. I underlined one of my reactants, and then I underlined my other reactant. This word combines is telling me to add, okay? And then to form is equals. So here I showed my math, okay? We have nitrogen plus hydrogen, which equals ammonia. And then I fill in the numbers, 28.0 grams of nitrogen plus 6.0 grams of hydrogen. I do my math, 28 plus 6, and I get 34 grams of ammonia. Remember, you get points for work, units, and answer. So make sure you have those units on there so that you can get full credit. That is the study guide. Good luck and study hard, guys.